Alright guys, today we'll be doing a tutorial on how to read the sextant, but it will also include how to handle the sextant and a quick revision on parts of the sextant as well. So I've made a separate video titled Parts of the Sextant, and I'll provide you a link of that one with this video as well so you can see it, because I'll quickly through the parts of the sextant. The focus of today's video is on reading the sextant. So how do you read the sextant? So I'll show you a number of different examples and you can learn how to read it. So firstly, I'll quickly start with how do you handle the sextant. So to do that, if you're a right-hander, and most likely you will be a right-hander, you will actually open the box and put the 5 fingers of your left hand into the box and hold the sextant as you see on the right side. You basically use your 5 fingers of your left hand and then hold the sextant and then take it out of the box, and then you can hold the handle of the sextant with your right hand, alright, for a firmer grip. And then if you want to shift it back, then you can shift it back into the 5 fingers of your left hand. Alright, so this is how you basically use the sextant. So if you are gripping the sextant by the frame, as is shown in this figure here, you do it with the 5 fingers of your left hand. And if you are holding the sextant to take a reading and you're a right-hander, you hold the handle of the sextant with your right hand and then hold it firmly, because you're a right-hander, most likely you hold it firmly with your right hand, and then you can use your left hand to clasp the index bar and move the index bar around as you read the sextant or as you use the sextant to obtain the altitude. Alright, so that's how you hold the sextant. And then we move into parts of the sextant. So I'll take you quickly through the parts of the sextant because I have a separate video title with it. So if you see all this is the frame of the sextant. This is the handle of the sextant, that is on the other side, which you normally grab when you use the sextant. These are the legs of the sextant on which the sextant is resting. Then you have the telescope, the index bar that you normally move with the help of the index bar clamp. So you press this clamp and you move the index bar along to move the sextant. And then you have the arc from which you read out the the degrees reading of the sextant. Then you have the principal scale, and that is what gives you the degrees. You have the micrometer scale, which gives you the minutes, and then you have the vernier scale, which gives you the reading in the decimals of a minute or in seconds. So the principal scale will give you the readings in degrees, the micrometer in minutes, and the vernier scale in decimals of a minute, or the unit can sometimes be seconds. Alright, and then you have the index mirror shades, you have the horizon glass, the horizon mirror. So the horizon glass is the top portion, the horizon mirror is the bottom portion of the same circular frame. Then you have the horizon shades, the first adjustment screw behind the index mirror, the second adjustment screw behind the horizon glass, and the third adjustment screw behind the horizon mirror. Alright, so I quickly took you through the parts of the sextant, and the reason being, I've told you before, there is a separate video, so please watch that video. It doesn't have an audio, but it shows you the different parts of the sextant and you can slowly go through that, and the sextant is labeled, so use that video to watch that. Alright, so today's video, the focus is on reading the scale of the sextant. So basically I've shown you before that the sextant is read of 3 scales. So the whole degrees can be read of the arc, and this is the principal arc, and this is where the whole degrees is. Alright, the whole minutes can be read of the micrometer drum, as you see here. So the minutes will depend on where the first line on the vernier scale is coinciding with the minutes. So you see the first line on the vernier scale is slightly different from the rest of the lines on the vernier scale. So that's the line, that's a 0 marker, and so wherever that line aligns with the line of the micrometer scale, that is how you read the minutes. Alright, then you have the fractions of a minute or seconds, which can be read of the vernier scale. So now you see the highlighted mark of the vernier scale, that's the 0 scale of the vernier scale. So wherever that scale is coinciding with the micrometer drum, that's the minutes. Alright, so in this case it's about 59 minutes. You can see, I'll tell you how to read the decimals of a minute after some time. Alright, because the zero marker of the vernier scale is coinciding, is coming after 59 minutes, so it's still 59 point some minutes. I'll tell you how to read the vernier scale shortly. So before we go into reading the scale, I want to show you something here through animations, that what happens when you rotate the micrometer drum of a sextant. So if you notice, the micrometer drum is right now on 0 degrees and 0 minutes, and you can see the principal scale, which is the right side just above the index spark lamp, is the principal scale, right? So you see where it is coinciding. Now as I will rotate the micrometer drum, you will see that the scale moves depending on the direction in which you move. So once you rotate the micrometer drum, give it 360-degree rotation, you can see that the marker on the principal scale also moved. So every time you give it a rotation of 60 minutes on the micrometer drum, because 1 degree equals 60 minutes, the principal scale marker also moves by 1 degree. So every rotation of 60 minutes on the micrometer scale will move the principal scale by 1 degree. I'll show it to you again if you missed it. So rotate the micrometer drum and watch where the marker is on the principal scale. So once I rotate the micrometer drum and give it a 60-degree spin, because 60 degree equals 60 minutes equals 1 degree, you can see that the principal scale has moved by 1 degree. So this is the basic principle of a sextant. Every 60-degree rotation moves the principal scale. You can of course also move it by clasping the index spark lamp and releasing it. Pressing it and then releasing it will also move the principal scale, but the finer adjustments are normally made by rotating the micrometer drum. So normally when you are reading or when you are trying to get the sextant altitude of the sun, you bring the sun very close to the horizon, and just when it's a few degrees or a couple of degrees away from the horizon, you make the finer adjustment with the micrometer drum, so that you get the sextant altitude of the sun just when the lower limb of the sun is slightly kissing the horizon. That's the phrase we use, kissing the horizon. Alright, so if I keep going, you can see what's happening here once I'm rotating the micrometer drum. So now I'll show you how to read the scale. So the first example here is that the sextant is set on 0 degrees and 0 minutes. So 0 degrees you can see by reading of the principal scale, and 0 minutes you can see by reading of the micrometer drum. So you can see the 0 marker on the vernier scale. There is only one marker on the vernier scale, and the vernier scale marker is coinciding with the 0 minutes on the micrometer scale. That's why 0 degree and 0 minutes. Alright, if I move on to the second example, you will see that the answer is 2 degrees and 0 minutes on the arc. Now what is on the arc and off the arc? Well, it's on the arc as you go towards the left of 0, towards the higher graduation, towards the markings with higher graduation. So from 0 you can go all the way up to 120 degrees. That is on the arc. Off the arc is, if you are facing the screen right now, to the right of your 0 is off the arc. So any marking to the right of the 0 which has lesser graduations is off the arc. Any marking on the left of the 0 as you are facing the screen with higher number of graduations all the way up to 120 degrees is on the arc. So over here it's 2 degrees 0 minutes on the arc. Alright. In the next example here, it's 2 degrees 0 minutes off the arc. Like I told you, if you go on the right side of 0, if you are facing the screen, the side towards the markings with lesser number of markings is off the arc. So when you go 2 degrees on the right side of 0, it becomes off the arc, and still it's 0 minutes. Alright. Then in this case here, it's 2 degrees, as you can see on the principal scale. The marking is just cross 2, and then that means it's 2 degrees. On the micrometer scale, you can see that the vernier marking is coinciding with 2 minutes on the micrometer scale. So you can see 0, 1, 2, 3, 4, 5. You can see how it's going. Although 1 and 2, 3, 4 is not written there, but you can see the order in which it is going. So because the vernier scale marker is coinciding with 2 minutes on the micrometer scale, it's 2 degrees 2 minutes on the arc. So you have to remember to name this as well, whether it's on the arc or off the arc, because I'll show you in a shortly what happens when it's off the arc. You have to do something differently. So it's important for you to know how to read the sextant when it's on the arc and off the arc, because when you get a reading off the arc, you have to do a certain thing to get the correct reading. Alright, so this is simple. Because you went on the left of 0, it is on the arc and it's 2 degrees 2 minutes. The next example is 2 degrees. As you can see, it's off the arc, because the principal scale, if you look at the principal scale, and the marking just below the principal scale has just crossed over 2. So for you to call it 2 degrees, the marking just below the principal scale has to cross 2 degrees. Alright, so if it has not crossed 2 degrees, it will still be 1 degree. So you have to look very carefully at the marking below the principal scale, whether it has crossed the above marking or not. So only if it has crossed the above marking, then it becomes the particular degree. So here it has crossed 2 degrees, so that's why you can call it 2 degrees. If it had not crossed the marking of the 2 degrees, it would still be 1 degree, although it may be very close to 2 degrees. If it has not crossed the marking of 2 degrees, the marking below the principal scale, if it has not crossed the marking of the principal scale, it will not be that degree. Alright, so in this case it's 2 degrees, it's off the arc. But if you look at the micrometer drum, to your eye it may seem it's 58 minutes, because the vernier scale marking is coinciding with 58 minutes on the micrometer scale. But the answer that you see above is 2 degrees 2 minutes off the arc. So the reason is, and this is what I was telling you before, that whenever it's off the arc, the degrees remain the way it is, but whatever you see in the minutes column, or the minutes on the micrometer, you have to subtract it from 60 to get the correct answer. So in this case, although to your eye it may be 2 degrees and 58 minutes, you will take that 58 minutes and subtract it from 60 to get the right reading. So 60 minus 58 is 2 minutes, and that's why it's 2 degrees 2 minutes off the arc. The subtraction from 60 minutes only happens when it's off the arc. The degrees remain unchanged, it's only the minutes that you subtract off 60. Alright, and this happens only when it's off the arc. Another example, here it's 2 degrees on the arc, because you can see the marking below the principal scale has just crossed 2 degrees, so it's 2 degrees. It's not yet 3, it's not 1, it has just crossed 2, so it will be 2 degrees. Now if you look at the micrometer scale, the vernier scale marking is coinciding with the micrometer scale between 2 and 3. We don't know whether it's 2.5, 2.6, 2.7, 2.8. Although I have written 2.8 here, sometimes this can be considered to be a guess. So when it's between 2 and 3, you can see it's more than 2.5, and it's not yet 3 minutes. So it's somewhere between 2.5 and 3 minutes. Since it's very close to 3 minutes, you have to make a guesstimate sometimes here, and somebody might say it's 2.7 minutes, I will say it's 2.8 minutes, but somebody might even say it's 2.6 minutes. So sometimes it's difficult to guess in a scale like this, but we know it's more than 2.5, so you have to take the best guess you can and then write down the minutes here. Alright, because the graduations are not given too accurately. I will show you where graduations are given accurately in a few slides. With a single marking on the vernier scale, sometimes you have to take the best guess possible, but you have to take a guess which is very close to the actual number. Again, this is here is 2 degrees off the arc. You can see the principal scale, the marking below the principal scale has crossed 2 degrees, so it's 2 degrees. It's off the arc because it's on the right side of 0 as you are facing the screen. It's towards the lesser graduation, so it's off the arc. If you look at the minutes column on the minutes side of the micrometer, you can see that the vernier scale marking is just crossed 57.2. So if it has just crossed 57.2, and again I'm guessing here, you might say it's 57.1, and we are both maybe right, but I have taken the best guess here and I'm calling 57.2. But when it's off the arc, remember what we do? We just take the minutes and subtract it from 60 to get the correct minutes. So because to my eye I see is 57.2, I will subtract 60 minus 57.2 and I will get 2.8, and that's my minutes off the arc. The degrees do not touch the degrees remain unchanged. Sometimes some students subtract 2 degrees 2.8 minutes, 2 degrees 57.8, 57.2 from 60 and they get 57 degrees something. That's incorrect. The degrees do not need to be touched. only the minutes. You take the minutes and you subtract it from 60. Now let me show you some examples of different vernier scales. So the one that you saw before, it had only a single marking on the vernier scale, and you were doing some kind of a guesswork when it was coming between two minute markings on the micrometer scale. This scale here, you can see the vernier scale is divided in intervals of 10 seconds. So you will use the zero marking of the vernier scale to guess the minute, or rather not guess the minute but read the minutes, and then you will see which of the markings on the vernier scale is coinciding with the marking of the micrometer scale, and that will be the correct seconds. So first let's start with the degrees by reading of the principal scale. You read it the same way that you were reading before. Look at the marking below the principal scale, and you will see the marking below the principal scale has not yet crossed 45. Now I know there are more than 5 graduations between 40 and 45, but you know that the one in the center is about 45. So I have doubled the graduations just to make it very clear to you. So the one in the center, which is slightly taller than the shorter ones, is 45, between 40 and 50. But you can see it has the principal scale, the marking below the principal scale has not yet crossed 45, so it cannot be 45 yet, although it is very close to 45. It has crossed 44, and that's why it's 44 degrees. If you look at the minutes, the one that is you look at the 0, 0 of the vernier scale and see where it is coinciding with the minutes. The 0, 0 of the vernier scale has just crossed 47, so you will call it 47 minutes. Alright, and then you see that the 10 seconds on the vernier scale is the one that is coinciding with the micrometer drum marking. So to read of the seconds, whether it's 10 or 20 or 30, you have to see which of the vernier scale marking is coinciding with the micrometer scale marking. So if I go back, you can read the minutes because the 0 is just after 47, so that's 47 minutes. But to get the seconds, see which of the vernier scale markings is coinciding with the micrometer scale marking, and you will see it's only the 10 seconds which is coinciding with the micrometer scale. So that's why you will read this as 47 minutes and 10 seconds. So the total reading becomes 44 degrees, 47 minutes and 10 seconds. The third type of, and it's on the arc, remember, because on the arc has higher number of graduations, off the arc only has a few graduations. So although you don't see 0 here and you don't know whether you are on the right or the left of 0, like I told you before, if you go on the left of the 0, the higher number of markings are there all the way from 0 to 120. But on the left side of 0, on the right side of 0, which is off the arc, you have lesser number of graduations. You don't go up to 40 degrees, you only go up to a few degrees. Alright, so let's show you the third type of scale now. The third type of scale here is in decimals of 0.2 of a minute. Alright, so let's get the reading of degrees from the principal scale. So you can see the principal scale here. I know the number of graduations between 30 and 40 is not accurate here, but I am intentionally showing you a number of markings here so that you get the idea of how to read of the marking. So assuming that the marking next to 40 is of course 39, going from 30 towards 40, but you can see it has not yet crossed 39. So what will you call it? You will call it 38 degrees. It's almost very close to 39, and you might be tempted to think it's 39. It's not. It has to cross the marking of 39 for it to be called 39 degrees. Currently it is 38 degrees. To read the minutes, first you have to read the whole minutes from the micrometer scale by seeing the 0 of the vernier scale. The 0 of the vernier scale is just after 32 minutes, so you will say it's 32 minutes. And to get the decimal of 0.2 of a minute, you have to see which of the vernier scale marking is coinciding with the minute scale marking of the micrometer, and you will see it's the third one from top of the vernier scale. So you can see this is 32 minutes, and then the third one is 0.4. So every marking is 0.2 of a minute. So 0, 0.2, 0.4, 0.6, 0.8, and then the next minute. And that's why this reading here will be read as 38 degrees, 32.4 minutes on the arc. Then the fourth type of scale here is in divisions of 0.1 of a minute on the vernier scale. So if you read the principal scale first, you can see the marking below the principal scale has just crossed 65 degrees, so I will call it 65. The minute scale, you see the 0 of the vernier scale, it's very close to 15, but it's not yet 15. It has not crossed 15. It's still 14. So I will call it 14 minutes. And then the decimal of 0.1 of a minute, you see which of the vernier scale markings is coinciding with the micrometer scale. Some of you may think it's 0.8, but if you look carefully, it's actually 0.9, the ninth marking of the vernier scale, right from top. So starting from 0, if you go down, the ninth marking of the vernier scale is coinciding with the micrometer scale. So it becomes 14.9 minutes. So the reading becomes 65 degrees, 14.9 minutes on the arc. Alright. And this is the final reading. And this is an example of off the arc. So we all know what to do when it's off the arc. You can see here the principal scale and the marking below the principal scale has not yet crossed 1 degree. The graduations are lesser on the right side of 0. This is off the arc. So will I call it 1 degree? No, it's not yet 1 degree. It's still 0 degrees because the principal scale mark has not yet crossed the 1 degree mark on the principal scale. If I go towards the minutes of the micrometer, it's 59 minutes because the 0 on the vernier scale is just after 59. So I will call it 59 minutes. And the vernier scale, see which of the markings on the vernier scale coincide with the micrometer scale. To my eye, it is the third mark from top as I go from 0 towards 10. The third mark from top, but but I guess it's the first mark from the second mark from the top. So you can see in this case the second and the third are very close. So my screen is kept at such an angle that I thought it's going to be the third mark, but you get the idea, right? Sometimes it becomes very close and it's difficult for you to find out. So take the best guess. I'm sure when you're reading the sextant, you will have some time and you read the sextant very carefully to see which of the markings coincide. So in this case, the reading will be 0 degrees. And although you see it's 59.1 minute, but remember with off the arc, you have to take it off 60 minutes to get the final reading. So it will be 0 degrees, the degrees remain unchanged, you don't touch the degrees, but 59.1 will be subtracted from 60 and you will get 0 degrees, 0.9 minutes, and it's off the arc. So that's all for today. I hope you understood how to read the sextant. I'll be putting up more videos about the sextant and other bridge equipments, and thank you for watching. To all my subscribers, I need to now pause this screen before this video